And let's organize our thoughts with sigma U equals delta T. And this U could be three things, right? The work done by gravity, the work done by spring, the work done by force. Okay. And so I like to go ahead and write, okay. So sigma U equals delta T. So the work done by gravity, mg h1 minus h2. That's on your formula sheet, but I think y'all can memorize. Just be careful. That's h1 minus h2. The way we derived it, and it's really because gravity is down, but it's mg h1 minus h2. That is the work done by gravity plus the spring 1/2 k x1 squared minus x2 squared plus, let me just put FD, but it might be integral FD, it might not even be applicable in this problem, equals 1/2 mv2 squared minus v1 squared. v2 squared minus v1 squared. Okay. And now let me read the problem, right? I know if I'm going to use work energy, that is the equation I'm going to use, kind of no matter what problem I'm asked. But this is a good problem for work energy because it says something about the velocity. Let's think about this. A 10-pound block is pressed against the spring so as to compress the spring 2 feet when it's at A. Plane is smooth. Determine the distance D measured from the wall to where the block strikes the ground. All right. If I tried to go from A, we'll call this all the way to C, I could do this equation from A to C. But that wouldn't answer the question. That wouldn't give me any distance D. All right, that wouldn't give me any distance D. This distance D is not that. It's not the same distance D. This is a distance if a force does some work on it. So not all D's, are in our equation. That X distance is not in our equation. Okay, so we can't use work energy to find that distance D. This looks like a projectile to me, right? So how about a projectile? Can we use our projectile equation from A to C? No, it is not a projectile from A to B. It is not a projectile from A to B. Projectiles are when they're flying through the air with no forces other than gravity on them. All right, so what could we do? Let's do work energy from A to B, and then we can do projectile from B to C, and then those projectile equations, we can get the X distance, the X position. Okay, I don't know if that's obvious, but that's what we're going to do. Break this up into sections, and this section A to B, I can use work energy, but then from B to C, it's a projectile. Maybe I'll go back to what we did for projectiles to find that. Okay, so from A to B, we're going to do work energy, and we're going to find the final velocity of that section, which will be the initial velocity of my projectile. Okay, all right, so MGH. We're going from A to B. MG, all right, so that 10 pounds is not the mass, that's the weight. So, I could, but do you see that M times G, that is the weight, actually. So I could divide by 32.2 and then turn around and multiply it by 32.2 right afterwards, or just say 10 right here, right? That mg is the weight 10. Then H1, I can set my ground to be wherever I want it to be. I think it makes sense to say it starts at 0 and it ends at 3. This is only the y, the height, right? it doesn't matter that it went 4 feet over to the left. I'm only concerned with the vertical distance for height. Plus 1/2 K is 100. And again, I should be careful with my units, but pounds per feet per second, gravity, feet per second squared. I'd like to have everything in feet. All right, so the initial compression is 2 squared, and the final, this spring is not attached, and so it just lets that box fly. So then it'll go back to its unstretched length. Plus FD. Is there any forces drawn on here? Any ropes drawn on here? Any external forces? Also, this is a smooth slide. The book might give you some problems that have friction. And friction, we could put it as that term because friction is in the direction, it would be negative because friction is one way, my distance is the other way. I think it kind of makes sense that friction is taking away energy. Now, technically, we would really kind of need to keep up with the thermal energy, the heat. We really want to do conservation of energy when we have friction. But usually, well, it really depends. Usually the heat doesn't affect the problem. So anyway, on the book, you might have friction, and that might be in this FD term. If it's constant and in the same direction, same line of action as the distance, and many times a kinetic friction is mu k n. So it's a constant mu k n if that n is constant. Anyway, all that to say, this problem, I don't think we have any FDs to worry about. All right, and so this equals 1/2 m. So now here, I definitely do need to divide by 32.2. V2 squared, so VB squared, and it didn't exactly, I think we can tell it starts from rest, right? You press it back and then you let it fly, let it go. And there, we only have one unknown, VB. And I would get VB 33.09 feet per second. I shouldn't box that in because I don't think it asked for that. We're trying to find the distance D. Well, we needed that, so now we can do a projectile equation from B to C. And again, we could do energy equation. That energy equation from B to C would be true. It would give us the final velocity at C, but it wouldn't give us any insight into the distance D that it travels. So let's do a projectile from B to C. How do we do projectiles? SF equals SI plus VIT, 1/2 AT squared. SF equals SI plus VIT plus 1/2 AT squared. So remember that energy equation, that wasn't an X equation or a Y equation. It was just magnitudes. It was just one equation. But here, go back to projectiles. Our axes matter. Now I need to think about positives and negatives, lefts and rights. So let's say that it starts at 0 and it ends at D, right? Think about that figure only in the X direction from B to C. I think it's helpful right here to remind myself, hey, I'm going from B to C. So this starts at D, ends at D, starts at 0, an initial velocity. Okay, well, the final velocity from the first part of the problem is now my initial velocity for my projectile part of the problem. Am I going to put the full 33.09 in here? No, I only need the X component. And so if this is, as it's leaving point B, it's at the angle that the slope is at. So it's at this 3, 4, 5 angle. So the X component will be 4/5 of 33.09 t. And there's no acceleration in the X direction for projectiles. All right, so there's one equation. Let's go to the y equation. I would say it starts at 3, it ends at 0. 0 equals 3 plus its initial 33.09, the 3/5 component, times t, plus 1/2, and now negative, we're in English units, negative 32.2 t squared. Why did I put that negative? Because back when we were doing projectiles, that's the acceleration, and that acceleration is down. I do plug in the negative 32.2 right there, because that's what we did for projectiles. Because that equation, the axes directions matter, whereas for MGH, I already factored that into my MGH equation. All right, so this equation right here, the only unknown is t. I can solve for t. I'd get t 1.369. Plug that back in up here. I would get a distance d, 36.2 feet. All right, not too bad. That's a great